Let's analyze some graphs of functions. We have f of x equals negative 3x plus 7. Perhaps you are familiar with something that looks like this. Y equals negative 3x plus 7. Well, this is a linear equation. And now we have a linear function. Do you recall how you graph lines? Well, more than likely, you either use the slope-intercept form, you determine what the slope was and the y-intercept. For example, we have negative 3 is our slope. Our y-intercept is 0, 7. You plot 0, 7, and you can go down 3 units into the right, for example, or you can go up 3 units into the left. That's one way to plot, but my favorite way to plot points is by using the t-table. So let's use the t-table. Let's draw a gigantic t-table. It looks like a T, as you can see. Our input is x. Put an x here. Normally we put y here, right? However, we have graduated to f of x now. So f of x equals negative 3x plus 7. Now we decide on points we want to plug in, or we decide on numbers we want to plug in for x. So we want to plug in negative 1, 0, and 1. If we plug in negative 1 or substitute the value of negative 1 for x, or replace x with negative 1, that sounds familiar, then this is also called evaluating a function. So what we're essentially doing right now is evaluating a function. So the f of x that we get, or the output, or the y value we get at this point would be 10. F of 0 equals negative 3 times 0 plus 7 would be 7. F of 1 equals negative 3 times 1 plus 7 will equal 4. So if we write our input and output as a point x and then y, or f of x, then our first point here will be negative 1, 10. We have 0, 7, and 1, 4. So let's plot these points on our coordinate plane. We start at the origin, which is 0, 0, in the very center, and we move left 1 unit and up 10 units. So when we go up 10 units, we end up here somewhere. Negative 1, 10. 0, 7. We neither go left or right, but we go up 7 on the y. 1, 2, 3, 4, 5, 6, 7. For 1, 4, we go to the right 1 unit and up 4 units. 1, 2, 3, 4. And as you can see, this is a good sign that all of our dots line up, right? Because this is a linear function. It should be a line. That's how you will graph. So let me ask you a question. What is f of negative 1 equal to for this problem? F of negative 1 equal to 10. What does f of 0 equal to? It equal to 7. What about f of 1? What does it equal to? It equal to 4. Now, using the graph below, determine if you can figure out the reasoning behind the solutions to the function notation. So what does this have to do with this graph over here? What is the connection between the two? What does f of negative 2 equals 4, f of 0 equals 3, f of negative 1 equals 3.5, and f of 2 equals negative 1 have to do with this graph in red? So at this time, pause the video, Think about it for a few minutes to see if you see the connection between the two. So hopefully you pause the video. Now, if you notice, we have f of negative 2 equals 4. We know that f of x equals y. So this is our x and our y. X is negative 2, y equals 4. So guess what? That is a point on the graph. Negative 2, 4. What about f of 0 equals 3? So 0, 3 is on the graph. Negative 1, 3.5. Left, negative 1, 3 point, go up 3.5. And then finally 2, negative 1. So those are points on this graph. Of course, there are millions of points on this graph, but we're just trying to show you the connection between the graph and those function values. So this again, these are called finding the function values based off of the graph. So I can turn around and not give you this and just ask you based off of this graph, what is f of 0 equals? Then at that point, if I didn't give you that information to the right, you would land at 0 on the x-axis and meet the graph where the graph is, and there it goes. What is that point? That point is 0, 3. When x equals 0, y equals 3. Likewise, if I ask you, just giving you a graph, what is f of negative 2 equal? You will go to the left on the x-axis, negative 2, 2 units to the left, and then you will meet the graph. Figure out where is that on the y-axis. That's when x equals negative 2, y equals 4. Let's try some more examples. Look at the graph of this function. Let's call it f of x. We're going to evaluate the following: f of 4, f of 1, and f of 3. Let's begin with f of 4. Again, you need to memorize that f of x equals y. So that 4 is our x value. So we go to 4 on the x-axis, which is here, right? Let me change my color. Go here for 4. And guess what? That is a point on the graph, actually. So that point is 4, 0. So when x equals 4, y equals 0. What about 1? Find 1 on the x-axis. We have to go up to meet the graph this time. Go up here. And what is that corresponding y? Corresponding y is 2. What about f of 3? We go to the right, x equals 3. And for this one, we actually have to go down to meet the graph. What is this point right here? Well, you can look to your left to see what y value it is. It is negative 2. Let's try another one. Look at the graph of a function g. What does g of 0 equal? So let's call this g of 0 now. G of 0 equals, well, this is when x equals 0. That is a point, right? 0, 0. What about 1? We go to the right, 1 unit, go up to meet the graph. What is that point? It tells you actually. Y equals 3. And what about 4? 4 is here. That is actually on the graph. That point is 4, 0. That's how you evaluate graphs, and that's how you find function values. Let's look at this example. Finding the domain and range of a function. Use the graph of the function f to find a, the domain of f, the function values, f of negative 1 and f of 2, and c, the range of f. Let's start with the easiest. F of -1, since we just went over function values, let's find the function value for f of -1. So when x is -1, we go to the left. We go up to meet the graph, and it's telling us when x is -1, y is 1. F of 2, we go to the right 2. We got to go down to meet the graph at this point. What is that point? What is the y value that corresponds to that point? -3. All right, let's go over domain. Domain again are all of the x values. So what we're going to do is figure out the lowest x value to the highest x value. We're going to write this in interval notation. So the lowest x value, now we're looking at the x-axis here. This is the x-axis. So we're looking to the left because the lowest numbers on the x-axis are on the left. So this is the leftmost point right here. The x value that corresponds to that point is -1. We're writing in interval notation because interval notation says we're going to write these two numbers and everything in between also applies. -1, that is a point on the graph. It is shaded in, therefore that point actually exists on the graph. So from -1 all the way to what? 5. So -1 will have a bracket because the bracket indicates included. That point does exist. However, is the point 5,2 really, does it really exist on this graph? No, it's an open circle, as you can see, meaning that the point right at 5,2 does not exist on this graph. All the way up to that point exists, like 4.9999999, but not 5 itself. So if it's not included, we indicate that with a parenthesis. 5 is not included. So this is interval notation again. It means from -1, which is included on the graph, all the way up to 5. So this is the lowest x value. So always write in numerical order, least to greatest. And this is your highest x value. Let's move on to range. Range involves your y values. So again, we want to find the lowest y value and highest y value. And everything, if we write it in interval notation, everything in between qualifies. So let's look at the y-axis. We're looking this way now. Where are the lowest numbers? The numbers that are lowest are at the bottom. So what is the bottommost point? This is the bottommost point, the lowest point of this graph. So that point is 2, -3. But since the y deals with the y values, we're only going to write down the y value, which is -3. It is a point on the graph. It doesn't have an open circle, so it is on the graph. We'll put a bracket there all the way to the highest y value. Now this is the highest point on the graph here. Therefore, we will put 3 down because 3 is the y value associated with that point. It is also included. So we'll use a bracket because there was no open circle there. Now, what is the relative minimum point? Minimum means lowest. Where was the lowest point? We just went over it. The lowest point was 2, -3. What was the highest point or maximum point? 0, 3. Let's try one more. Use the graph of the function f to find A, the domain of f, B, the function values f of 0 and f of 3, and C, the range of f. Let's go with the easiest, f of 0 and f of 3. We need to find the function values for those. F of 0, this is 0 here. This is our point. It actually gives you the point to help you out. When x is 0, y is 3. What about f of 3? Go to the right, 3. Go down, meet the graph. When x is 3, y is -6. Now let's talk about the domain. The domain again involves the x values. What is the lowest x value on this graph? Well, don't forget, we are looking from left to right. Now, when your graph is parallel to the bottom of your coordinate plane, that means that your graph is going on and on forever like this. So where is this going towards the left? It's continuously going in this direction, -infinity. All right. So now we're going from left to right. Left, we're going up, and we hit a pot in the road, a hole in the road, a pothole. So that's -3. We won't include it because there's a hole at x equals -3. But then we start back up. We put union. Union, that's the symbol for union. It looks like a U. And we keep going and we don't have any more issues after that. So from -3 to positive infinity. Again, notice we put parentheses because x equals -3 was the only number excluded from the domain. In fact, you could have written this answer as, I put or, the domain could have been written as all real numbers if you want to write it out, all real numbers except x equals -3. All right, one more, range. Range again, we said were y values. We need to find the lowest y value up to the highest y value. So the lowest y value, if we look on the y-axis, where are the lowest numbers? The lowest numbers are at the bottom. Now, if you notice though, our graph is continuously going down, down this direction. So that's from -infinity. And then it looks like it's going all the way up to this. This is the highest y value here. What is the highest y value? Not x value, but y value. It is 3. It is also not an open circle. Therefore, it is an actual point on this graph. So we will include it by using the bracket. Now, you probably were wondering, what about this? This is a hole. But notice that -6, this is covered on this end. This is -6, right? So -6 is actually covered on this end, but not this end. So since it is, this function does cover it when x equals 3, then we do include -6. -6 is inside this interval. So -6 is included in the range. Now, if both were holes, this was a hole and this was a hole, we would have to skip that -6 and write this a little differently. It wouldn't be the same answer. But since this one, -6 is covered on this side for the range, then we do, it's almost like this fills in the hole in a sense. All right, this covers function values of graphs and finding the domain and range using a graph.